Hello everyone, my name is Abhishek and welcome back to my channel. Today is day 26 of free AWS DevOps Zero to Hero series, and in this video we will deep dive into a concept called as AWS Load Balancers. Now I think you all understand how important is AWS Load Balancers because I keep seeing in the comment section, Abhishek, can you please explain about load balancers? What are the different types of load balancers that are available on AWS, and explain a realistic comparison between these load balancers. That means right now AWS has three different types of load balancers that are supported, and people are asking me to explain with a real-time examples because the documentation is slightly confusing. So that's why in this video, I'm going to explain you what are these three different types of load balancers and using real life use cases. That means practically when you need to use ALB, which is application load balancer, when you need to go for NLB, which is network load balancer, and when will you choose GWLB, which is a gateway load balancer, right? So in this video, we are going to understand these things in a very, very detailed way. That means right from fundamentals, I'm going to explain you how each of these things is different from one another. Now, before I go into this video, I have to explain you two concepts to make sure that everybody is on the same page. Then I can go ahead and explain about these concepts in detail. First is all of us need to understand what exactly is a load balancer. Then the second thing is we need to understand how a packet flows from the client to server. That means how a packet flows within the 7 layers of the OSI model. Now you might have studied, if you are a computer student, or if you have taken computer education, then you know that there are 7 layers in the OSI model. But what I'm going to do in today's video to bring everybody on the same page, I'm just going to give an overview of these 7 layers, right? So let's start with the load balancer first. Basically, why you need a load balancer? Let's say that I'm an application developer and I wrote a game application, let's say, and I've deployed this game application on a AWS EC2 instance. Now, initially, when I started promoting this game, there were only 5 users. Okay, user 1, user 2, user 3, user 4, and user 5. So they are trying to access this game on this EC2 instance. Now it is going fine because there are only 5 users. So concurrently, my game can handle 5 users and there is no problem. But after a while, the game that I have deployed here has become very popular. And now instead of 5, there are actually hundreds of users. Okay. Now it is quite obvious when the number of users has increased, this one single instance cannot handle the load. Okay. Because there is only one single instance, it will not be able to concurrently serve all of these 100 users. So because of which, what will happen? Some of these users might see the slowness of your application, or some of these users might also see the downtime, which is a very bad user experience, right? If they are seeing slowness or downtime, that means your application is not giving a good user experience. So to solve this problem, the simple way is that instead of deploying it in one EC2 instance, what you can do is you can create multiple copies, or you can create multiple EC2 instance. Let's say this is EC2 instance 1, EC2 instance 2, and EC2 instance 3. In 3 EC2 instance, you will deploy your game application, or it can be any application like e-commerce application. And in front of these 3 EC2 instances, you will place a load balancer. Okay. What you will do? In front of these 3 EC2 instances, you will place a load balancer. Now there are 3 different types of load balancers, but let's not go into the details of it at this point of time. Let's assume that you have deployed a load balancer. Now for these hundreds of users, what you will say is instead of accessing the EC2 instance, just access the load balancer. So all of them will try to access the load balancer. And now it is responsibility of the load balancer to manage the requests and to manage the load onto these EC2 instances. Let's assume that all 3 EC2 instances have same characteristics. Okay. Let's assume that all of these EC2 instances have same specifications such as RAM, CPU, type of operating system, everything is same. Then a basic load balancing mechanism can be round robin. Okay. So there is a very basic load balancing technique called as round robin. And what this load balancer will do, if there are 100 requests, it will simply forward 33 requests here, 33 requests here, and 33 requests here. That way, instead of one EC2 instance handling hundreds of requests, now each of them only have to serve 33 people. Let's say if this is not enough, you can increase the number of EC2 instances and load balancer can manage the load. So what is happening with this? The slowness and the downtime, users do not face these things. So you can provide a highly available application. So the general technique of creating a highly available application is by using a load balancer or is by placing a load balancer in front of your applications. Now you might ask me that, okay, Abhishek, here you told round robin. Are there any other load balancing techniques? Yes, there are hundreds of load balancing techniques. It depends upon the type of load balancer you are using. So there are many load balancers in the market. Like for example, Nginx is a load balancer. F5 is a load balancer. Envoy is a load balancer. Or you have, for example, let's say Traffic is a load balancer. You have Ambassador, which is a load balancer. So you have lot of load balancers in the market, and each of these load balancers have or support different types of load balancing techniques. So round robin is a very basic one that I've explained you. Let's say if one of these EC2 instance is a highly powerful instance compared to the other instances, then you can say your load balancer to send 50 requests here, 25 requests here. You can also configure those things, which is called as a ratio based load balancing, or there is weight based load balancing, right? So there are different load balancing techniques which we will cover in this video. But for now, I hope you understood the concept of what exactly load balancer is. Now, once you understood what exactly load balancer is, now let me explain you the second thing that is very important to understand. That is, what exactly are the seven layers of OSI, or how does usually a packet transfer or a packet travel from your client to server. That means when you have a browser, let's say you opened a Google Chrome browser and you search for a website called google.com. So from here, how does your request travel and finally reach one of those Google servers? Okay. And again, the response is sent back to you. So this entire thing happens with happens in 7 layers. So let's try to understand that. Okay, let me explain with a very simple example. Let's say that there is a user. Okay. Now this user want to access linkedin.com/Abhishek.Veeramalla, for example. Okay. So what this user will do? So this user will open his or her favorite browser and search for LinkedIn/Abhishek.Veeramalla. So user has initiated a request. Now this request will travel over the internet and finally it would reach one of the LinkedIn servers. And now this LinkedIn server will respond back with the Abhishek.Veeramalla's user profile, and user will be able to see linkedin.com/Abhishek.Veeramalla because the server has responded back with a HTML page or a web page or whatever it is. So this is how the traffic flows. But what is happening internally? So internally, your request from the client or your request from the user is traveling and reaching the server in 7 different layers. Okay. So the traffic flows through 7 different layers and finally the request will reach the server. Now you might be thinking, but Abhishek, why I should understand about these 7 layers? What is the advantage? You need to understand because different load balancers act on different layers. For example, application load balancer would act on layer 7, whereas the network load balancer is pretty effective on the layer 4. So you need to understand what these layers are. I'll not take much time. I'll explain you in a very simple way in next couple of minutes. After that, we can go ahead and understand the application load balancer, network load balancer, and GWLB. So to start with, what will happen is, okay, if I have to explain how this request flows through these 7 layers. So let's say that this request initially started with the user accessing linkedin.com/Abhishek.Veeramalla. Now what has happened is when this user opened his favorite browser, right? So there this user has initiated a HTTP request. Okay, so this is called as an application layer. Okay, so application layer is the one which is layer 7, where you decide what kind of protocol you want to use to access the server or to talk to the server. So it can be HTTP protocol, it can be your FTP protocol, SFTP protocol, right? So these are the different types of protocols that are available. Now, using the application layer, you will decide what kind of protocol is required. You might be thinking that, but Abhishek, when I open the browser, I'm not specifying that I want to initiate a HTTP request. But your browser is basically, is a HTTP client, and it is basically creating that HTTP request for you. Let's say you are using any other things like Postman or something. There you explicitly mention what kind of protocol you want to use, right? You want to use HTTP protocol or something. So browser does some kind of automation for you, but you can understand that when you open the browser, you are initiating a HTTP request when you want to access linkedin.com/Abhishek.Veeramalla. Now from layer 7, that is from the application layer, your request goes to layer 6, which is called as presentation layer. Now, what happens in the presentation layer is, so the request that you are sending, right? Should this request be a secure request, or is it okay if you want to send an insecure request? So if you want to create a secure request, then there should be something like SSL or TLS, right? So you want to send a SSL based request or a TLS based request. SSL is deprecated. Now everything is TLS. So this thing happens in layer 6. That is the presentation layer, which will typically take care of encoding your request or encrypting your request. Then you have layer 5, where in the layer 5, basically you are creating session for your request. So you basically deal with the session objects, right? When the server receives the request, this server wants to understand few things about the session that this user has initiated with the server, right? In the session object, you can get details like, okay, what kind of client has requested, and when this request is created, all the information related to the session that is created between the client and the server. So this thing happens in layer 5, that is the session layer. And from there, this goes through the transport layer. So transport layer is a very critical or key layer, because in the transport layer, your request is split into multiple packets, or it is split into small chunks. So this is called as layer 4. And this transport layer will make sure that your request is transmitting from the client to the server in a secure way and in small packets. Okay, so that the connection will not be like when you send a huge request to the server, then there can be a delay in the response from the server to client. So if you split this request into small packets, then server can easily read the packets and it can send response again in small packets. That happens in the transport layer. Then it will go to the network layer, that is layer 3, where once these small packets are created, then these small packets have to travel from user to server through multiple routers, right? So this is where your network layer comes into picture, where your request goes through multiple layers, through multiple routers, and finally your request would reach the data center, right? So then comes into picture the layer 2, that is the data link layer. So where you have all the switches, right? So your request will go from one of these routers, the final router before the server. Let's say this is the final router before the server. So what will happen is your request will go to a switch, right? It will go to the data center, and from there it will go to the physical layer, that is layer 1. Now in this physical layer, what happens is, you have all the cables that are connected to your servers, right? So let's say this is your server. This server has to be connected with a cable, right? And from the cable, it has to be connected to a switch. And from the switch, it has to be connected to a router. So this switch and everything is basically your layer 2. And here, when there is this cables, right? So this comes under your physical layer, and finally it will go to the server. So this is how your packet flows from the user to the server, right? So it will firstly start with the application layer where you define the protocol, HTTP or anything. From there, it will go to the presentation layer where you will decide if it has to be a secure one, you need to do any encrypting, these kind of things. And then it will go to the session layer where you will decide to create a session object. From there, it will go to a transport layer where your request is segregated into small chunks, and re- request is securely transmitted from the client to the server. Finally, it will go to these routers, right? There will be a final router before the server. From there, it will go to the data link layer where it can go to a switch. From there, it will go to cables, and from cables, it will finally reach the server. So this is the entire flow of the packet, or this is the entire flow of the traffic. So till now, I've explained you about two important concepts. One is what exactly is a load balancer. And the second thing that I've explained you is what are the different layers that are involved in the traffic routing. Now, depending upon these two things, we will decide which load balancer to use. That is, should we go for ALB? Should we go for NLB for our applications? So who will decide this? DevOps engineers and the application developers together will decide, should the applications require ALB? Should the applications require NLB? Taking into considerations these two things. Now there is another thing which is called as GWLB, which is a complete different thing. I'm going to explain about this one after I explain ALB and NLB. Now, how do we decide? Depending upon the load balancer and depending upon the layers on which load balancer to choose. So if you want to perform traffic load balancing on layer 7, then you should choose application load balancer. If you want to perform traffic load balancing on layer 4, then you have to choose the network load balancer. So what was layer 4? That is the transport layer. And what was layer 7? That is the application load balancer. So let me break this down and explain even more simply. So layer 7, like I explained you, is mostly we will deal with HTTP traffic in this layer. While this is application layer, there are different other protocols such as FTP, but let's talk about HTTP. So if you want to perform load balancing at the HTTP layer, that means when a user creates a request, when a user initiates a request, if you want to intercept the user's request at layer 7 and decide upon load balancing, depending upon the host or depending upon path, depending upon domain, etc., then you can choose an application load balancer. For example, let's say I am accessing amazon.com, okay, amazon.com/payments. Then my request has to go to a particular service, which is called as a payment service. If I am accessing the load balancer on amazon.com/transactions, then my request has to go to the transactions target group. Okay. Or if I'm accessing amazon.com/login, then it has to go to the login service group. Okay. So what you are trying to do with ALB is when you use an application load balancer. Okay. So user tries to access application load balancer. Let's say the application load balancer the domain is amazon.com. Okay. When you create application load balancer, you can configure it with a custom domain or the domain that Amazon automatically allocates you. Let's say you are using a custom domain called amazon.com. Now user can access amazon.com on different paths depending upon applications. In the load balancer, you can configure, okay, if the request is coming from, if the request is sending to amazon.com/ABC, then forward the request to one particular server group. If the request is going to XYZ, then forward it to another servers. Okay, so who can make this decision? Application load balancer. And now because you are doing this at the application layer, so that's why this is called as a L7 load balancer. Okay. What are the different other capabilities? At the L7, you can intercept your HTTP request, the HTTP request that user is sending, and you can read the HTTP request. That means what are the headers that user is trying to send? What is the path that user is trying to access? What is the host? That means, for example, is the user trying to access Amazon.in or Amazon.com or etc. etc. Or you can also perform ratio based routing. That means looking at the number of HTTP requests, you can say that, okay, send 10 requests here, 10 requests there. So these are the different kind of routing mechanisms, or different kinds of load balancing techniques that you can perform using application load balancer. And why this application load balancer is called as application? Because it is performing at the layer 7. It is making the decision of routing depending upon the HTTP request that you are trying to send it. Now, not just this, it can also perform additional capabilities like, you know, it can perform SSL offloading, right? That means even if you send a plain HTTP request to load balancer, this load balancer can initiate a secure connection to your servers. Okay, that way probably you are sending a plain request, but load balancer is sending a secure request. So at least the connection from load balancer to the server is secure. Okay, it can also perform re-encrypt, pass through different types of SSL mechanisms, which is not in the scope of this discussion. But one thing to remember is ALB is a costly load balancer because it has many additional, or it has advanced capabilities. It can intercept a HTTP request, and depending upon the HTTP request that it has intercepted, it can it can decide the load balancing technique. It can decide which server to forward the request. So because it is intercepting and providing you additional capabilities, it is a costly thing. And the second thing is it is slightly slow as well. Why is it slow? Because there is a layer which is stopping, right? You are sending the request to ALB, and ALB is analyzing your layer 7, and then it is forwarding to the servers. So there is a hop in between, or there is a stoppage in between. So that's why ALB is costly, and it is also slow because there is a latency involved. Now let's talk about layer 4, that is transport layer. Okay, or the NLB. Now, I told you that application load balancer acts on layer 7, whereas the network load balancer basically acts on layer 4. Now, let's say you don't want to perform routing depending upon the request or the HTTP request that is sent to you. Okay, let's take the same example. There is a network load balancer. Okay, and there are some applications. Now, a user has sent a request to the network load balancer. Network load balancer cannot intercept your HTTP request. That means it cannot perform any intercepting and any modifications at the layer 7. But when the request comes from layer 7 to layer 5 to layer 4, there NLB can play a critical role, where it can play a critical role in the transport layer. And who requires this kind of routing? So there are some things like your game servers. Okay, there are some things like your, for example, YouTube streaming platforms. They require layer 4 routing. Why? Because at the transport layer, like I told you, transport layer is the one where it transmits data in small chunks, and it ensures that the data is transmitted from client to server without any latency or without any issues. Like, there should not be like loss of data. That is the one that transport layer is taking care of. So when you are using network load balancer, this load balancer can ensure that there is low latency, high transmission of data, and it can work very well for these kind of things, that is game server or YouTube streaming platforms, where even a simple delay is not expected. If you are using application load balancer here, what will happen? It will intercept the request at layer 7. So there is some kind of delay which you will not accept when you are doing some video streaming. Or, when you want to perform load balancing without any interruption, then go with network load balancer. Okay, so in real time, your request has to be sent to the network load balancer, and network load balancer, depending upon port, depending upon IP address, it can forward the request to your servers. Let's say you want to access YouTube streaming server, then in front of your YouTube streaming servers, you can place a network load balancer, and network load balancer, depending upon the request, it can quickly decide, okay, should it go here, should it go here, should it go here, or should it go here? Okay, so it is less costly, network load balancer, and the other thing is that it will not involve in any kind of latency. That means it is very fast compared to the application load balancer. And where is it used? It is most popularly used in the game servers, YouTube, streaming platforms, video streaming platforms. This is the places where network load balancer plays a critical role, and it acts at the transport layer. So basically, it performs routing on the TCP and UDP packets, not on the HTTP packets. So I hope this is clear on when to use ALB and when to use NLB. So in your organization, let's say there are application servers, let's say there are web servers, where you don't want to intercept the request on the HTTP layer and you want high transmission, you don't want any kind of delay, then go for network load balancer. Whereas if your applications are something like game servers or video streaming platforms, okay, where you want to perform advanced routing techniques, then go for application load balancer. If some kind of delay is expected, but you want to do load balancing on the layer 7, then go for application load balancer. Now, finally, there is something called as GWLB, which is a gateway load balancer. Now, gateway load balancer is a very, very simple thing. Here, gateway load balancer is useful when you are dealing with some kind of virtual appliances. That means, let's say you are using a VPN kind of application, whereas you are working for a customer that deals with firewall kind of applications, VPN kind of applications. In such cases, you have to front face these kind of applications with gateway load balancer. Now, you might ask me that, Abhishek, let's say that I'm working for a company where they are using firewall applications. Okay, let's say my company is building firewall applications. What will happen if I front face an application load balancer here? Okay, instead of gateway load balancer, what will happen if I front face a application load balancer? Now, the kind of traffic that these firewalls receive, okay, these firewall kind of applications receive a specific kind of traffic that an application load balancer cannot handle. Okay, and the other thing is that, okay, you can use some proxying. Okay, you can do some proxying and you can make it handle this kind of requests. But the other problem is that application load balancer does not add capabilities of security. Now, the same thing is with network load balancer as well. You can say that I can front face, instead of gateway load balancer, a network load balancer or ALB. But when you are using this virtual appliances such as VPN or firewall, your traffic has to be highly secure. Application load balancer or network load balancer can offer some kind of security, but gateway load balancer offers high security, and it sends the encrypted packets to these virtual appliances. Okay, highly encrypted packets to the virtual appliances, which network load balancer and the application load balancer cannot offer. Also, for the kind of traffic that these VPN applications or firewall applications receive, network load balancer and application load balancer not the suitable things. So when you want to use, or when you are working for a company that develops virtual appliances such as VPN or firewall, go with gateway load balancer. Okay, when you don't want to route the traffic, or when you don't want to apply the load balancing techniques at layer 7, you are okay to perform and execute load balancing techniques depending upon your layer 4 traffic, then go with NLB. Whereas if you want to perform different kinds of advanced load balancing techniques, go for ALB. Okay. So YouTube, video streaming platform, content streaming platform, there NLB comes into very much handy, because with NLB, there will not be any kind of delay. And when you are using YouTube or these kind of content streaming platforms, delay is not expected. And one additional advantage of using NLB is that NLB can create sticky sessions. Okay. Because let's say you're watching a 3-hour long movie on YouTube, or you're watching 10-hour long content on YouTube, then all your requests has to go to one specific server, right? In such cases, if you are placing a ALB in front of these video streaming platforms, what will happen is one packet, like 10-hour whole thing can be one request, but one packet will go to one server and other packet will go to another server. In such cases, this will not work. If all your packets goes to one single server, because this entire video is one particular output that you want to send to client, right? So in such cases, you only have to use NLB, because NLB creates a sticky session. That means the first request that load balancer has sent to server 1, then all the requests from that user will be sent to server 1 only. So these are some of the things why you should use NLB when you are using content streaming platforms. I hope you understood the difference very clearly. What are the different kinds of load balancers and when you have to use this load balancers. So I'll see you in the next video. Take care, everyone. Bye.